the second part, and we're going to move to the third part of our video, in which we're going to make a more complex example using the fxmap node. So see you there. Okay, so we're moving into the last chapter of this video, and I think this one is the most interesting and more useful part. So I think definitely this is something that I haven't seen in any substance designer tutorials so far, and this is something that you should definitely know and understand. And I think for these examples, I'm going to create something like a plant or like a branch of a plant, but I think this idea, this concept, it's going to be very, very useful and very natural for using fxmap and using loops and using nested loops and branching and switches and things like that. So let's get us started, right? Okay, so fxmap node, make it grayscale, go inside, make it to a maximum blending mode. The pattern should be a disk. The pattern size should be 0.05, even less than that, 0.005, and the same for width, 0.005. Okay, so it's a point in the middle. And then I will be using an iterate node for this, and we're going to start simple but build from that, and you're going to see how actually powerful this is and what really working procedurally means. You're going to see the amazing amount of control that that you could get by using those or these ideas and techniques, right? So connecting this, set this thing as a root. Good. And up to this point, I think you just need to probably watch this part a few times. This really took me kind of like 1 year to figure out. So I've made around 50 or 60 examples, and literally I just had to go through it and try to guess it and try to come up with a workflow that makes sense. So I think in the beginning it might be apparently confusing, but I can assure you that once you get it, it totally makes sense. I think this part of the tutorial is going to be a bit more difficult, but if you're brave enough, I think this will definitely pay off and definitely will raise your level of understanding in Substance Designer, and you'll know more if you go through this and really fight to understand the ideas and the concepts. So be prepared. Going inside, I will start to use variables and things like that. So first of all, I'm going to use some naming conventions. I don't know why, but I liked how we have in Houdini some variable names, and basically I just borrowed from that and used the numpt and ptnum notation. So I'll be using that. Feel free to use whatever you want. You don't have to follow exactly what I want, but for some reason I just stick with that. So I'm going to do something like this. I will be creating like the main body of the main part of the branch, which is basically like the main spine. So this is the first thing that I will do, and I will just type like a float here. So float, and then I will be maybe using like 1024 for this. I will be setting this to So I will be naming this numpty0, and then I will be using a sequence node out of this, and then just turn this into integer. So I created a variable. This variable just stores the number 1024, and then I took this number, which is a float, and then I convert it into an integer, which is the thing that I want to output from here. So this is just a bit more appropriate way to do this kind of stuff. So it's kind of the same thing like this. Just took a iterate node and set it to 1024. So it's almost the same thing as this, but not just doing it manually. So currently I will be working procedurally and with variables. So I set like 1024 iterations. I named this variable so I can get it later, and then I will be setting this as an output. Okay, perfect. So now nothing changed, but it executed like 124 times. I need to go here into pattern offset and then just get it. So I need to get the float dollar number. Remember, we need it. I want to set this. So I'll be setting this to ptnum0. Okay. Then I will be using a sequence node. So now I get ptnum0, which I can get because I just set it, and then I will be divided by numpty0. Float numpty0. So kind of what happens is like this is the I++, this is the thing that goes from 0 to 1023, and this is just the division by how many iterations we have, which is a constant number. It's this number that we set here. So numpty0, it's 124, right? Numpty0, it's 124. Now I just go here if I want, change this value only here, and then it will update here as well. So this division, I made it, but I also want to store it in a variable because I will call or use it later. So I will be setting it to t0. Again, feel free to use whatever naming conventions you have, but it's important to have like I have 0 and 0. And this is important to kind of establish the level at where you are. So I'll be putting here like 0 because I will be growing my graph up and down. So at least I should know what level I am at. So I'll be having like whatever goes up is going to be -1, -2, minus whatever, and whatever goes down is going to be plus and things like that. And this is just my convention. You can feel free to improve or do whatever you feel like makes more sense for you. But you'll also see what I mean a bit later. Okay, so currently we made a few computations. Now we want to also do some stuff. We need a starting position that we want to update over time. So go back here and float 0, 0, and we want to set this as pos 0. Sequence, do this, do this, do this. Now everything is chained correctly, yeah, so we kind of have 3 lines of code. In this line of code we assigned a 0, 0 to the position variable, then we assigned 124 to numpty0, and then we lastly output this as how many times we want to iterate. Great. Now we want to take this and update the position. So we want to get the position, which I think it was called 0, right? Pose 0. So going back here, we want to get 0. We want to add something to it, and we want to set it back again. So this is taking like every time it iterates, it's going to take the position, is going to add something to it, and is going to make this one as a current position. And then in the next iteration, the information from here gets passed into here, and then the cycle repeats. So this is now the position. This gets added to it something, and then it's right as a new position. This new position gets here, and it repeats this like 1024 times. Okay, so set it to pose 0, and then do this and set this one as an output, because this is what we want to output here. We want to output a position. So great, nothing happened yet, and that's totally fine. This is because we didn't add anything here, but maybe did. I think maybe it should have happened something here. Let me think about it for a moment. Why didn't it do anything? I think it should do something. So position 0 was set, pattern of set, we executed this. Oh yeah, no, that makes sense. Yeah, we really added nothing to it. So currently it's like this. So nothing changes, right? That totally makes sense. But then I will use this Cartesian thing, and I believe I also need to compute one more thing here. Okay, get float 2, I need to compute the size of 1 pixel, and this is size, and then float 2, 1 and 1, and division, and swizzle, and set, and this is going to be 1 px, and then sequence this as well. So I'm storing this computation in a variable called 1 pixel. And you will see in a minute what I'm doing right now. Go here, and into this thing I plug this, nothing changed, but then when I get float 1 px, this is the radius or the length of the vector, and if I plug this here, you can see how we created a line. So what happens is that I have circles that I have 1024 circles that are 1 pixel apart from each other, and this is actually creating a line. So this line is created by very close dots or disks together. So now that I have this distance from each disk to the other disk, I also want to use this angle to make this line curve or follow a path. So maybe I will do something like this. I will use a constant number to show you what's going on. So if I put this thing here, and if I change it, you can see how it's rotating. So maybe I can rotate it like this, and I can go back in here and just say like, hey, the position, maybe change the position and make it something like that. Just want to make like a branch of a plant that starts from here and then somewhere like here. Maybe, I don't know, we'll see. So we have it like this, and currently, because this is a constant, you can see that it's a straight line, but I can add to it something that changes in time. So this is like the main orientation, and then I can add to this something that changes, and we have this thing that changes, t0. this pt num 0 divided by num pt 0, it's something that ranges from 0 to 1 and it's stored in this t0 variable. So get float and t0, it's already here, and if I plug this thing, you can see how the entire thing curved, and that's great. I kind of like it. Maybe I can do it to be like so. Okay, so we're having a basic shape that it's that's curving, and this is our start point. Maybe I can do something to it. What if I want, for example, to have it wiggling a little bit? So maybe um, go like a wavy line, something like this. Let me show you what I mean. So now I have this thing going on. I will ignore this curved part for a bit and just put it aside. I will be taking this thing that goes from 0 to 1. I will be multiplying it by maybe, let's say 18. I mean, I need a float for that. I can't just type 18. And then this goes from 0 to 18. Then I need to put a sign after this, so this is turning everything into -1 to 1. And then maybe I can just add this thing here and see what's going on. So now I have everything which is making this curve, which might be interesting, I don't know. But I want to blend between this and this. So you remember this was like a curve, like so, and this was like a wavy thing, and maybe I just want to blend between these things. So let me actually do it like this, delete this part here, and I will be just blending between those two things. So remove this. This is curved down. This is this wavy part, and I want to make a transition between those two. So I can do a linear interpolation, which is just the blend node. So lerp this and this, and I can put this thing here, and it requires another thing that we want to put here. For example, I can put this, and this is like exactly like the blend node. You have the top layer, the bottom layer, and this is like the opacity. And then once you do this, it changes from the curvy line to the, I mean, this is the curved line and this is the wavy line, right? And you can blend it like between these two. But I also can do another cool thing that allows me to blend along this path here. So I can make it to be like, once it starts, it can be like this, and then it ends, it can be again like this, but in the middle, it can be wavy. So for this, I need to take this thing, and I also use color for you to see what's going on. For debugging purposes, for you to understand what's really going on. But give me a minute. So this is ranging from 0 to 1. I need to multiply it by pi. And then I just put a sine node after this. So all this computation, what actually gives me something that starts from 0, goes to 1 in the middle, and then gets to 0 back. Okay, so if I do this, I get this kind of effect, right? Where it was like this in the middle, it was like this in the beginning, then it turned like this in the middle, and then returned to this at the end. So maybe I can just multiply this by more. Maybe, I don't know, 64. I wonder if this is like totally correct. Let me just check it because I said that I will be testing this for you. So let me go into luminosity, and we're going to use luminosity a lot for debugging purposes. And at this point in time, I actually feel like moving all my computation in luminosity channel would be really beneficial. But for now, let me just get the dollar number variable, right? Dollar number, and we want to divide it by get float. We have it like um it was num pt 0, so this should be from 0 to 1. If I output this, yeah, it starts 0 and ends with 1. But then I want to make sure that if I multiply this by pi and then I put a sign after this, it goes like 1, it goes like 0 at the beginning, full 1 at the middle, and goes back to 0 here as well. So yeah, indeed. So you can see it's like that. So it means that we are currently blending between this and this based on this transition, like how it's here. Okay, so kind of in a way I like it, but also it feels a bit weird, so maybe I can play with this a bit more. So maybe I should take this range from here and change it. So put like a power node after this and float. Maybe if I put like a 2 power, it's changing like this, maybe like a 4 power. So you can see how our effect, our wiggly effects start to be more concentrated, like in the middle. Maybe if I put like even 8 here, you can see how it's getting restricted here in the middle, which is something that I like and I want to do. But also I want to decrease, so those wiggles are a bit like too extreme and I want to change them. So multiply the amplitude of my sine wave. That's interesting. Why is this happening? If I do this, I should get like a total straight line. This makes sense if I do this. And then, oh yeah, no, it makes sense. Yeah. Okay, so then I just multiply this by a small number. This is going to start and introduce the wiggles for us, kind of like this. And I think maybe I just want to blend between this and this. So this is my curvy line, okay? And I want to also add this as well. So curvy plus this, I mean wavy plus the curve should be giving me this. Yeah, this is what I want. So I want to blend between the curved line with the waves and then just the curved line. So this is just the curved line, this is the curved line, the curved line with the waves, and I want to blend between these two things based on this thing here. So this at the bottom, this at the top, and then now this is the blending. Yeah, so this is the effect that I wanted. Okay, and maybe I just want to bring back some of the spread in those ways, so not having them just in the middle here, but maybe more like, yeah, something like this, and then just add. Yeah, perfect. So I have my branch like this, and I want then to rotate it. So currently it's orientated in this fashion. I don't want this. I want to just change the rotation. Okay, now reduce some of this waviness bit. Okay, so again, to recap, this is producing us a wavy and curved line. This is just the curved line. This is a blend between the wavy curved line and just the curved line based on this gradient here, which can be seen in the luminosity channel. And then at the very end we reorientate the entire thing together, so we rotate it. Okay, so this is the position, and I will be doing this and call it angle. Okay, now get back into luminosity and just output everything as one for now. Okay, so this is our current shape of the branch, and you'll be seeing a bit later that we can change a lot of the aspects, like the length, the actual path, the luminosity, the thickness, the orientation. We have great control over all these things. Good. We have this thing already happening, and I want to branch from it, so I want to have branches. So for this I will be taking this node and move it apart and introduce a branch, like a switch, sorry, and point this here and point this here, so our drawing actually reappeared. And it's good that we already created the logic here, but we want now to take it and move it from here to here. And you're going to see like this is helping us to propagate the computation and the variables through the tree. So for example, the variables that I created here will not be accessible, or they will not exist in this part of the tree. So now we need to actually take this computation and move it here such that the computation and the variables are existing like higher up in the tree, and they are accessible and visible lower in the branch and towards the leaves. Okay, so you're going to see what I mean in a bit. So for now, for this to happen, I just need to take this entire computation and copy it. Just copy this code, go here into the selector, empty, paste everything together. Now if I want to set this thing as an output, I can't, because this is wanting us to output a boolean type, which is a true or false statement. But no worries, we're going to do this in a bit. So for now I will be just using a dummy boolean, which is just a false one. Sequence node. So we're doing this switch node in order to create branches from this main stem, and this allows us to take this code and branch. We have this part here going on, which is the main thing, and then we're going to branch from it branches actually of this main stem. Set this as an output. You can see that something changed. The entire length of everything got larger, and this is because our position got computed twice. So now was computed here, but also was computed here. So I need to get back in here and just take this one and set as an output. So now we only need to call this variable which we computed above here, and we can delete everything else. Good. So up to this point we managed to move the computation here into this part of the tree, and this allows us to have the information existing and being reachable by other computations lower down the stream. But now we want to make the actual branch. So let's say that on this main stem we have a bunch of branches. How do we do this? Well, we're going to use this one, this node, and we're going to duplicate it. So let me delete it. I took this one, duplicated. Why did I do this? Well, it's already having some information or some preset. It already has a disk. The size is correct. Maybe for this purpose I want to do it a bit larger so you can see what happens when it happens. Okay, and then plug this thing here. So nothing happens yet, and the reason for nothing happening is because this switch node only executes this part. So this outputs only a false thing. So if I go inside, you can see this is set to false. False only goes into this branch. I also need to make it sometimes to be true. And when this is true, actually the information is going to flow through this point here. I mean through this wire into this branch of whatever we're going to do here. So let us do this. I already have this ptnum0, right? So I want to take like ptnum0, I mean get float. Okay, and I also have this numpty0 which I can duplicate, and I want like at some point in time this ptnum0 is like 0 to 1024, or maybe from 0 to 1023. I want to make it like at some point in time this is going to be equal to um, some numbers, and I want to, when this happens, I want to create branches. So how do I do this? Well, if I remember correctly, maybe how did I do this? Okay, so what I need to do is this is a list of numbers that goes from 0 to 1023, and I need to kind of make another list of numbers that sometimes is equal to some of the values in this one. So I can take this and divide it by maybe a number like 64, for example, and then just take the floor of this. So maybe I think you can imagine that this is going from 0 to 1023. Dividing this list of number gives another list of number that is having like a lower bound, but also is going to have some decimal points. So this is a list of integers 0, 1, 2, 3, 4. If I take this list and divide it by 64, it's going to um, have a list that also have like decimal points and floats. And then if I take the floor out of this, then it's going to remove all the decimal points and make integers again. This is kind of like how the quantized grayscale node works, where it's taking like a smooth gradient and it's turning it into like a stair step effect. So I'm currently doing this. So I just made the steps right now, but now I want to multiply this back by 64, so I get back into the same range. And then if I do this list of number equals with this list of number, at some point in times we're going to have those two lists having equal numbers, and then when this is happened, this entire thing is going to be true, and then information is going to be passed on this branch here. So if I set this to here, you're going to see that now we have those points here, which means that now we're viewing results from this branch here. So if I delete it, no more points. If I put it now, I have the points here, which means I created like the roots for these new branches. And they're like equal spacing. It's starting from here to here. I may be able to fix this. Maybe show you how like what's going on. So currently this 64 means that I have like 64 points in between all this thing, But maybe let's say, hey, what if I wanted to just put like maybe 8 points in total? Well, how would I do that? Well, you just take this numpty 0 and you divide it by this, and you just change this from here to here. So now I currently have like 64 points in total, but if I want only 8, I just type 8, and you can see like 1, 2, 3, 4, 5, 6, 8, 9. Well, of course, maybe did I count it? 1, 2, 3, 4, 5, 6, 7, 8. No, it's 8 point. I don't know why. Forgot how to count. Good. Also, I want to move this maybe in the middle so it doesn't start like in the beginning. And here maybe I can move the entire thing to start, or I mean to end here and to start somewhere here. So I need to take this number divided by 2. And then add it here at the end. Add. Okay, right? So now everything offsetted correctly. So I want to make the nodes a bit cleaner. Maybe this is like so, and this is like so, and just comment this is like our number of branches. Number of branches. Okay, I also want to use this computation to be able to call it later. So this is position, we stored it, we need it later. We also want to use this thing from here, so set, and I'm going to call it ang0 from angle 0. And use another sequence node like so. Okay, good. So I can move this a bit out of the way, and this may be like this. Well, great. We updated our position. We also stored our angle. We also made our branches. Here now it's time to actually create some branches. So we have the starting point of the branches. Now we want to actually make the branches. So in order to do so, we need to put like another iterate node that's going to allow us to do the same thing here. So do long things stemming from those points here. So iterate, and then put this in here back. And at this point, we need to do a few things here. So go inside this one, and just want to remember this would be like our level 1. We had level 0 here, we're having level 1 here as well. And want to go back in here and to remember this was numpty 0. I will be copying this part from here, so I went here, just copy that part, going back here, paste this, change this to numpty1. Also, I need to take in the position variable and change its name. So we had pose 0. Is this a flow2? So get flow2, pose 0. Now it needs to be, pose 0 needs to be set to pose 1. Otherwise, you're just going to end up overwriting the same variable and it's not going to do what you want. So critically, take now when you do this switch and you're trying to use this as a starting point, you need to take the current variable, which is called position 0, and you need to change its name and to set up into this new position 1. And we're going to take this new position 1 and update this, otherwise it's going to give you like a messy result. So position 1 it's here, and now we want to go here, set this one as an output, Now make this maybe 512, not as long as the main stem. And then go in here in pattern offset. We want position 1. We want to add something to it. We want to set it. Okay, good. Also, we want to do our things in here as well. So get $number. We want to set it. We want to make it ptnum1. We want to do a sequence node. We also want to make our t1 variable. So get float ptnum. This one should be divided by numpt1. So division should be set to t1. Okay. We need to do this thing sequence. Okay, so if I output this thing, nothing happens, but then it means that we're missing this part here. So again, we need to put our Cartesian node here, and then we need to put our length here. If you remember, our length was that variable which we called 1 pixel. So get float 1 pix. And now we have this thing going on, which is a good starting point. Maybe at this point in time we could just decrease this value and this value, maybe 3.5 and 3.5. Okay, now we want these things to follow the original curve. Yeah, and how do we do that? Well, we already computed and stored that variable. So if we go back in here, you remember that we have this computation which was called angle, and it's stored in this thing ang0. So what happens is that this variable here stores all those tiny vectors that pushes the or construct this line. So I have a dot here, and then I have like a small vector that goes from here to here, and it stores this information, and then step by step it's constructing this line. But then when we have this switch node and we have this branch, at this point in time, this information gets passed from here, which means that now I can access this variable to just orient my line to follow or to be aligned with this entire branch. So each line is going at its point, it's going to be aligned with the main direction of the branch at the relevant point. So you're going to see this happening now. So get float. So it's ANG0, right? I think that was. So now you can see all my branches are aligned properly. And maybe I can just go here and decrease this maybe to something like, I don't know, 64 for now, and do this thing maybe like so. Okay, so you can see how the lines are oriented with their direction from the point of branch. Okay, good. But now I want them to actually diverge from the main direction. So for example, I want them to follow like to be like a certain angle from this base angle here, right? So now I can do this, and I just need to add a value to this, like add and float. So I'm going to add this and see what's happening. So you can see like how everything went together. And at this point in time, I want to show you another trick. Let's say that I want to have those lines be like one in this direction, considering the main direction of the path, and this one should be on this direction and this one should be in this direction. So have them alternating the angle. How should I do that? Can I even do that? Well, I can do this, and I think it's a really cool trick, and hopefully I'm not going to screw it up, because for some reason, even though I have like 50 or 60 attempts and projects like this, I still kind of mess it up. So hopefully I will not be messing it up. Well, let me do this, right? So I need to go in here, and I think the background music is a bit distracting. So let me go back in here. So what I really need to do is actually I need to count how many times this switch actually became true. And for this, I need to create a variable, and I need to create this variable above this. So I will be counting how many times this switch was true. So this is false, this is true, and I need to count how many times it was true. So for this, I'm going to go here above a level. So I need to declare a variable that can be updated here. I need to create the variable here above it. So float 0, and I'm going to call it set. And I usually call this val 0 from value, and it's your val 0. And again, feel free to come up with a better name. I'm pretty sure my naming convention it's not ideal at all, but I'm doing this, or I'm using this naming. So now I have created the value, and then one step below I need to actually update the variable. So I'll be moving this, maybe I think I already have the space. So I need to get the float, which is called val 0, and then I need to add 1 to it. And then I need to do an if else statement. So if else, and if this is true, so we're doing this is where we're actually doing the branching. When this is true, then take my value and increase it by 1 if it's true. If it's not true, if this thing is not true, just keep my val 0 how it was, and then after this thing just go and put like a set node and val 0. Okay, so I'll increase my val 0 by 1 whenever this thing is true, otherwise leave my value 0 alone, and then connect it to everything by just making it another line of code. Okay, so I hope this should actually create something like this. Whenever this is true, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. If I should be able to color these things, I should be seeing 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Let me now try to use this thing to make those alternating stuff. So going here into offset, I have this 0.78. If I put a minus here, now they're like on the other side. So 0.78, this is like how initially it was. If I put like a negative node, negation node, I have them. So I need to kind of switch between these two things. Well, I will put a lerp node. Okay, so maybe it's something like this. And then you can see if I put a value here and play with this value, it's actually blending between those two 0.8 and minus 0.8. But I actually want this not to be a constant, but I want to be something that changes, and better would be something like 0, 1, 0, 1, 0, 1, 0, 1, and so forth. So I'm expecting if I take this val 0, if it's already working and if it's already 0, 1, 2, 3, 4, 5, 6, 7, 8 or something like that, then I can take the mod 2 of it, float, mod 2, and mod 2 it's actually kind of making every even or odd numbers 0 or 1. So if I just plug this in here, I have it like so. Well, great, we made it. We made like alternating branches, right? And I think this part is starting to get already interesting. What should I do next? Well, yeah, I want to make a few tweaks. I want to make like at the beginning, like where things start together. At the beginning of the branch, I want those angles to be more spread like this, and as they go towards the top, I want those branches to kind of point more into the direction of the main branch itself. And for this, I will just increase the number of those branches so we can see the effect better. So maybe I want like 32 things going on, something like this, right? Okay, and then yeah, it means that I need to kind of add something to this, and how to actually do this thing. So we have our initial angle, that's good. We also have this thing alternating. Where should I play with stuff? Well, I think this is the value that I should be playing with. So this is initially, if I leave this to or closer to 0, you can see like it's following more the orientation of the main branch. If I increase this value, it diverges. So then what if I could actually change this with something that's not a constant? So this is a constant. With what if I could change it with a variable? And I have a variable that keeps tracks of how things are moving from here to here. So I have a variable that actually keep tracks of values along this main branch, which starts with 0 and ends up with 1. Well, that variable was called tier0, so I can get it, and it's called t0, right? And what happens if I plug this? Actually, it's t0. So if I replace this, what happens? Well, you can see I have some effect going on, which it's already interesting, but I want this to be in reverse, right? So I said that things to be spread here at the beginning and to be more close together here at the end. Well, I can just put a 1 minus, well, it's on 1 minus, and now this reversed the effect. And 1 minus, it's actually like the invert grayscale node. So this is what it's doing. And I can maybe here at the end everything is like really close together. Maybe I don't want that. I can just add a bit more spread again with a value, something like this. So maybe now I can spread things. Yep. Okay, interesting. So what's going on? So I have a variable that's changing from the start of the main branch towards the end of the main branch. So I can control this already, and this is assigned to the spread. But also I want to make these branches at the beginning, I want to have them longer than the ones at the end, right? So how should I do this? Well, where I control the length of this, well, the length of the those branches is controlled here. So if I change this value, you can see how I change. But as you can see, this is a constant, right? And maybe I don't want a constant here. So I will be getting again what variable do I want to use. Well, t0. T0 is the one that controls how things are changing along the main branch. So get float t0, and I want to do a linear interpolation between two values along this branch. So lerp, and I will be doing this and this, maybe two values like so. So maybe 64 and 256. And just for safety reasons, I will be doing something a bit more redundant. There should be a better way to set things up. I just want to cast this to an integer because this interpolation actually gives not integers, and I want them to be integers. Like I would have some, I don't know, like some 128.5 or whatever, and I don't want to have that. So maybe I can just put like an integer, or maybe like just a floor. I don't know, maybe a floor might be better. Okay, so now if I do this, well, I got the reverse effect. Maybe I can just switch between these two. So I'm just selecting these two wires, maybe doing the switch and stuff like this. Okay, so I have the branches here at the bottom longer than the ones at the top, which I think it's already interesting. Maybe do this like 48 or 32, and then maybe do like 300. Okay, what if I want to do some randomness? Um, Maybe those things here shouldn't be like equal all the time, right? You can see that they have like the same length. Maybe we should add some randomness, right? So of course I think we could do that. Where should or how should we do it? Maybe I will just add something here. So add, and how or when should I add randomness? How have I done this before? Where I add it here? First of all, let me try and add a random node here. I think it should be appropriate. So what really happens is that this this thing, I mean all this tree gets executed like 1024 times. So if I put like a random node here, I think whenever this gets run, that random node will generate uh, a new random value, right? So let me try it like this. So maybe float one random. Okay, so this should generate like every time this node is executed, it should generate a random value from 0 to 1. I want to make this from 0 to 1 to -1, 1. I also want to multiply it by something, maybe 16. So this is going to do like plus or minus 16 randomness, and maybe it's too much, we're going to see. And then if I add this, let's see what happens. Yeah, so things have changed, and you can see without it and with it. Okay, I think it's an improvement. Maybe even we can put like a 32. Yeah, maybe 32, I think it's good. I kind of feel these wavy lines here are producing those chaos here, which in a way I'm not sure if I like or not. So I'll be for the moment just reducing this wiggle here. So the wiggle was controlled by this parameter here. So if I set this to 0, now we don't have wiggles at all. And then maybe I can just increase it. It was like 0.3, maybe 0.1, maybe like this. Yeah, for now. We'll see later. Okay. I still think maybe those branches are a bit too large. or not too large, too thick. So maybe we can add thickness to them, but also change the thickness in a way that is more thick here at the beginning, and towards the end they get thinner. So I think by this time you might be guessing that I will be using the T0 parameter again to control this thickness and to actually blend between a few values. So great. Well, I'm going to do this here. Here is where we can control the thickness, but from experience, it would be good to just disconnect this for a while and now go in here and into the pattern size, go inside and get the T0 parameter, load T0, and then, I mean, it's T0, and then lerp, and then I need to actually put two values. So this T0 goes into this, and those two values that I want are float is like 0.005, and I don't know, it was like less than that, it was 3.5, and then this is one value, and then I could just do another one here, but what I usually want to do is multiply this by a smaller number. So let's say that I want the other value to be half of this one, so I can just do like 0.5 here. So whenever I change this is going to be automatically just half of this one, and I think this is like a good practice to do. And then just cast this into a vector flow 2, set it as an output, and then do this connection again. So the reason for doing this disconnection is because if I would have this and go inside here, whenever this is an empty function, it's going to automatically do the pattern size to be 1, and 1 it would be like a disk of the entire size of this texture, and this is a 2K texture, and I think I already have maybe 60 or around 60,000 circles here, and it would be like 60,000 large circles on top of each other, and this might cause Substance Designer to crash. So that's why I disconnected it first and then went into the pattern size itself to change it. So as you can see, now those branches here at the beginning of our leaf or stem or plant or whatever it is are thicker, and then towards the end they get thinner. So I can even emphasize this more, and instead of 0.5 I can make it like 0.25. So you can see like at the end things get thinner and thinner, and I think I like this effect, right? Good. So now I want to do another thing. I want to curve those branches. So I want these branches here to be curved in this way downwards, and the upper ones to be curved upwards, like in this way. And for that we should go in here, pattern offset. Here we have our angle, and let me think where we actually should play around with this. So I think here we could play around with this, so maybe it's in here. Yeah, this is where we can add or subtract things, right? So I can take this original or main thing, and how do we curve this actually? Well, we already used T0 to control the orientation along the main branch, but now we want to control the orientation of the vector along the branch itself. Well, how or what should we use for that? Well, we already computed this variable which is called T1. So add, we should add get float and T1, right? And T1 is just curving those things. So good. It means that what we wanted is happening here at the bottom. That's really good. Then we want the reverse to happen here at the top. So maybe if I put a negate after this, what happens? They curve like this, which I like. Let's say and then I want to blend between these two things together. So I'll put a lerp, linear interpolation. So now I have this and the float here. Okay, so now it's like this, and then if I play with this, it's making the transition between the two, right? But instead of this, I want to use something that is changing and not a constant. And how do I want to do? Well, I want at the beginning to have the branch pointing down, and then I want them at the end to point up. Well, it's good. What variable allows us to do this? Well, T0, right? So I can get T0 again and then just plug it here. So now I can see I get like at the beginning, I get the branches like this, and then at the top, I get them like that. Well, in a way, maybe, I don't know, I like it or I don't like it. I think maybe they are curving a bit too much here at the end. Maybe I can play with this to adjust things more. For now, I think maybe like this can be fine. Uh, I'm not a big fan of what's going on right now, but I think it can be fine, right? Also, I want to say that maybe I can change things. So I have the branches here at the bottom, not be as long, but maybe have them shorter. So let me do this instead. Maybe it's going to look more interesting. So again, where am I controlling the length of those branches? Well, here I'm controlling. So instead of blending just between this, so this is like the longest, right? And these are the shorter one. I can tweak this variable here not to go linearly from beginning to end, but I can make it like start with here it should start with a length of 32, then in the middle it should reach this maximum length, and then finish at the end again with this. Well, we've already done this before, but we're going to do it again. So we need to multiply this thing by pi, and then we take the sign out of this. So this is changing like T0. If you imagine T0 is just like a linear curve going from 0 to 1, but this is doing something else. This is taking this curve and making it start at 0, go in a curve and arriving at 1 in the middle, and then going down to 0 at the end. So this is what's this function here doing. So if I plug this in here, I'm in the reverse, which is interesting, but I don't want that. I just need to switch this, okay? So, I mean, I think I like this shape a bit more, right? Yeah, maybe not 400, maybe a bit less. I think, yeah, maybe 280 might be good. Okay, and you can change this all the time and have more or less branches and change the angles and change the randomness. We should also add a bit of randomness to the angle itself. So currently we have it like this. All these follow the curvature of the main branch, but we can also add some randomness to the angle in the way that we added randomness to the length of the branch, right? So let us do this. Where do we do this? Well, I think we did it correctly here. It seemed that this worked. So maybe I can just use this thing that we already computed here and store it and reuse it. Okay, so this worked correctly and I just want to use this part. Maybe this part. Yeah, and I'm going to set it to set, and I will name it R1. R1 it's from for random one or something like this, and then use a sequence node. I put the sequence node here. I just drag the variable here. I like to have my variables aligned here, and then all the sequence node like so. Okay, so everything is connecting neatly. Then here is where my angle is computed, and then I can probably add the random here as well, right? So this is where things happen. And then I want to add, and then I will add R1. So get float R1. Sorry, not this. Okay, so it's working, but it's too much, right? So I want to tone down this effect by multiplying it by something. Now it's multiplied by 0. Of course, it doesn't do anything, but then you can just go in here and do this. So yeah, you can see it's adding randomness. Okay, perfect. So it's working. If you go in here and just do like random seed, you're getting different configurations of your parameters. Okay, what should we do next? So we have everything going on so far, but we want to do more. So we want to put branches on branches. So what should we do? Well, we kind of already done this before. So we take this one, move it here, add a switch, go in here, go to here. Now everything seems to be just fine. But we need to take what we've been computing here and copy this part above, so we have access to the information on this new branch that we're going to create. So we need to put everything in here. We just pasted it. We made another new sequence node, so we can just set this as an output. For now, we're going to put a dummy boolean, which is false, and set it as an output. And we should see what? We should see our branch is getting longer. Why did this happen? Well, it happened because we computed pos1 2 times, right? So it means that we can go in here and in here, and we no longer need all this computation. We just need to take pos1 and set it as a variable, as an output. And yeah, everything can be deleted. Well, perfect. We need to take this one, or we can duplicate it and then put it in here. We can also take this one, duplicate it, and put it in here. And then we need to change a few things. So this was level 0, this is level 1. This should be what level? Well, level 2. Go inside to this one. We're going to just do a bit of cleanup. For now, we don't need this. Don't need this, just do like simple stuff for now. Maybe just 32, and we're going to redo all these things back, like all the things that we've been deleting, we're going to do them again. We need to rename things. Pos 0 needs to be changing to pos 1, pos 1 needs to be changing to pos 2, numpt1 needs to be changing to numpt2, sorry. Okay, this can be left as is for now. Then go in here, pattern size, maybe just reset it and then set it like 0.002 and 0.002. I mean, no, maybe just something larger so we can see them. That's just for preview. And then seems everything is right. I think so. Maybe go here inside. Instead of pos 1, we need to get pos 2. Great. So we need to get in here and actually decide when we branch from this into smaller branches on this one, right? Okay, so let's do this. Go in here, move this thing back, I mean down. We already have position. We want to also store our new angle. So set. Okay. So you can see how here we had angle 0. Now we're going to store it into, you guessed it, angle 1. ANG G1. Okay, sequence like this, like this, like this. Okay, good. So we want to branch from each and every one of these. So how to do it? Well, we need to take this again. We had this configuration, so ptnum. We need to divide this, maybe like float. How many do we want? Well, let's say that I want maybe 16. So for each of those branches, I want 16 bifurcations, right? And then I have this, so I need to take this thing, divide it by this, floor it, multiply it back, and then test for equality between these lists of numbers. So I have this list and I have this list here, and then we check for equality to see when those lists are equal to each other. And if I put this, we can see that we have this result, which I think it's weird. Why? That's really interesting. Where did I screw up? Okay, so it seems that we're not getting the result that we want, and there is a fix for it. And I need to uh, probably think a bit more about this, because in this current setup that will allow me to specify exactly how many points do I want. But we can just change this for now, and instead of do this division, I can just use this 16 here, right? So what's happening right now, instead of saying like, hey, I want exactly 16 points on each of those branch, I can specify that I want the spacing between these points to be 16, right? And in a way it makes sense, because if you look at things, this branch has only maybe 3 points, and this one, which is longer, has many points, and it makes more sense to establish or to define the spacing between points rather than for each branch do maybe a certain number of points. This should be a topic in which I will be looking into, or you should be looking into, and figure out how to do for each branch. Maybe you want exactly to do like maybe 16 points for each branch, then how you would do it, right? Okay. Maybe I think the density that we currently have, I think I like it. But we might be changing it in the future. Okay, so now we have things like this, and I want to do branches from those points. So I'll be doing, I already have this loop here, just going inside this one and add set pose to set as an output. Nothing happened yet. That's fine. We need to do a bit of housekeeping. So get float, we need to get dollar number, and we need to make our t2 variable. So set this to ptnum2. Okay, should spell correctly, ptnum2. Then sequence, then get float and get float. So this one should be ptnum2, this one should be numpty2, this one should be division, okay, this one should be t0, t2, sorry, set t2, t2, Yeah, it's getting tougher to type correctly. Sequence again. So maybe we're in good shape. I will be outputting this. Nothing happened yet, but we need to add things here. So Cartesian, um, that's the node that we want. And then once I plug our magnitude or length of the vector into here, we're going to get things moving. So get float 1 pixel. Now we have it. Now that we see things, I want to just decrease this to 1 to 5, 1 to 5. Okay. Going okay so far. Maybe go in here and decrease the brightness of those of the secondary branches. So maybe, I don't know, for this one, I just want to show you another thing that you can try and do. So for the main branch, we have those secondary branches alternating. But then for this one, what if I want to have like double branches? Like I want one of them to go like in this direction and the other one to be like opposite. So not alternating, but having from the same spot, I want to have like one branch here and another one here. Can I do that? Well, yes, I can, but I need to add another loop node or like another iterate node. So let us do this. So iterate, okay, plug this thing here. This one can be just like 2 here, so it executes 2 times because this is how many of those branches I want per thing. So I want like 2 times, one in this direction and one in the other direction. Then I need to go in here and do something. So maybe, yeah, I need to do not like this. Go inside. I will be copying from this. So I will copy from this thing, go in here. So we have a numpty2, right? That's good. This needs to change to just 2 instead of 32. Just 2. We don't need this floor here anymore. Set this one as an output, and this needs to change here inside. So now we have 3 numpty3. Also I need to get float dollar number, so I need to take the dollar number from here and store it in here below it. So dollar number, this is now this is now set, this is now ptnum2. Okay, so because we added things, now this is level 2, 2, not q, and this is level 3. So needed to change things. So here I change this one to ptnum2, this one to numpty3, and then I need to go in here and also adjust to that. So here the dollar number, it's actually ptnum3, and this one is 3 as well. This one is 3 as well. This one is t3 as well. Now it's correct. Okay, well, good. Now we need to do something. So for example, float, just add like a value here and just do something like this. And maybe if I just put like a negate, I get them like on the other side. But here I think it doesn't work this way, so I just want it like opposite. So here I think I just need to add, and I need to add like an 180 degree, which is like just pi. So this and this, okay, and I think this is going to be not too painful to adjust, that's totally fine. I think like I'm just setting things not the ideal way, or maybe no, that should be totally fine. I mean, I should get yeah, that solves it. I should get the angle 1 that I have, so the angle 1, so get float ang1, and I should be adding it to it. Okay, so I can delete this one. Okay, and then if I negate this, I get the opposite, so negate. Yeah, so I want to somehow blend between these two values, and I already have them here. I just need to put a lerp, linear interpolation. And if you remember, we had a variable stored in ptnum2, which is executing only 2 times. So this is executing 2 times. And the dollar number here is like 0 and 1. And the linear interpolation actually wants to have values between 0 and 1. And if I put like 1, I mean, if I input the ptnum2, here it's going to give me exactly what I want, because ptnum2 is like in the first iteration it's 0, which is going to output this, and in the other iteration is going to be 1, and is going to output the other thing. So get float ptnum2, and then do this, and I think if everything is correct, we're going to have double branches, which we do. And also I think it's looking interesting. So of course, we can do more stuff with it. And the first thing that I want to do is we want to adjust like the width. And if you remember, we have like those branches here, those secondary branches are like larger at the bottom and thinner, I mean not larger, but thicker at the bottom and thinner at the top. And I also want this trend to follow with those this new level of branches. And how should we do this? Well, we already computed the we already have computed the thickness, but we didn't store it in a way that allows it to be accessible. So currently the thickness for those branches, it's in here in pattern size, and it's on this branch. So this information, whatever we computed here, this information doesn't exist here on this branch. So what we need to do is we want to take this information from here and move it above. So we can take this thing here, copy it, and put it in here. Yeah, so we can just copy paste and then store it, set it, and we're going to name is thickness and thickness 1, because this is the level. So everything we have, all the variables are like ptnum1, t1, pos1, ang1, and this is going to be thickness 1. Thickness 1. Well, I think I should be copying this thing. Control plus C, and then use a sequence node, and then do this, and then do this, and then do this. So now everything is connected. We have all variables, all our variables. It's getting trickier and trickier to speak. I'm getting tired, but we should carry on. So in pattern size here, I can just get the float and paste this thing, and probably nothing changes. I just want to look at the top. I'm looking at the thickness of this gray thing, and if this doesn't change, it means that I did good. Well, I didn't do good because it disappeared. Where am I? Where am I? Well, thickness 1, thickness 1. What did I do wrong? Did I do anything wrong? Well, thickness 1. It's like between T0, T0 already exists. Oh yeah, now I totally get it. So what I've done wrong is just I took a float instead of a float 2. So it didn't recognize this one. So in here in pattern size, this is just a get float, but it needs to be a get float too. So now thickness, and then set it as an output. Now nothing changed, and this can be deleted. And then I can already take this thing, copy it, and then just go in here and into thickness I can paste it. But remember, it might crash if I just do it directly. So currently the pattern size is manually set, right? And if I go and hit or click this one, by default all my disks are here are going to be equal to 1, which is going to create like a zillion circles here, which might crash Substance Designer, and I don't want it. So disconnect this thing for now, go inside, go in pattern size, and just paste this thickness one, set it as an output, and then reconnect things back. And now surely we have thicker branches here at the bottom and thinner ones at the top. And I can just multiply this by half. So scalar multiplication, float, and 0.5. And now it's cool because everything is interdependent. So if I go one level upstairs, so here I control the length or the thickness of those branches. If I just go in here and change this value, you can see like we can control everything together, which is fine and nice. So we have this going on, and I want to do the following. I want to add well, I want to tweak a lot of things about it. First of all, maybe let's tweak the length of those branches. So I want the branches to be shorter at the beginning and longer at the end, right? But also maybe have even more control, maybe have the length of those have the length of these branches being driven by the length of this in the first place. So maybe at the bottom we have those branches being shorter, and then at the top we have them how currently they are. I think maybe the thickness here is a bit too thin, so maybe go back in here into size and not 0.5 but maybe 0.75, so it's like 75%. Yeah, that's better. Okay, good. So now let me do this. Well, where do we control the length of the branches? We control the length of the branches here in this node. So currently we have 32. Maybe we could have like something like between 16 and 64. Okay, I think I like this. And then we should do a linear interpolation, lerp, between this and this. And initially we're going to do the length is going to be controlled by this thing. So get float, we have t0 that it's helping us. So now we have at the beginning longer and at the end shorter. I don't know, maybe it's good. Maybe I wanted to have like in the middle here, so I'll be doing the sign trick. So multiply by pi, and then sign, and then do 1 minus. Okay, so I think this is interesting. And okay, so this is one thing that we want, and then we also said that maybe we want to have them be shorter at the beginning of these secondary branches and so on. So now we have it like so. We then multiply it by how we want them to be small. So maybe float a percentage, maybe a quarter, so 0.25. So now they're shorter, right? And we want to blend between this and this. So we're going to use again the lerp node between this and this. And now we're going to mix between with the t1 variable that we have, t1. And also needs to be maybe in reverse. That's interesting, but also maybe I wanted this. Well, that's not quite good, but we can do this. So the sign trick as well. So multiply by pi and then sine. Yeah, I think this is better. Yeah, I feel like I like it this way. We should also do some randomness here as well. So we can add float 0 random 0 1 to -1 and then add this thing. That's interesting. I didn't expect this to happen. That's really interesting and unexpected. So I currently have values between this is doing between 0 and 1. And if I added things here, maybe without the minus, maybe without this, I think. Yeah, that kind of didn't work. So maybe, yeah, this is just adding a bit of randomness. It's not subtracting, it's only adding. So it's elongate everything. It doesn't shorten existing lines. It's just elongating everything. Okay. Now what can we also change? We want to also add a bit of randomness to the angle. We also want to curve this. We also want to add randomness to luminosity. So let's add first of all randomness to the luminosity, because I want to show you something, because adding randomness where it's important is good. So what I want to have each individual blade have a random grayscale value. If I just go in here where I actually draw them, so here is where I draw them. If I go in here and go into this luminosity and then just go like float random, it's going to color, I think, if I'm not mistaken, it's going to color every single point that makes those lines is going to be randomly colored, which it did. So you can see like we have like randomness things. I mean, it doesn't look bad, but this is not what I want. I want every single branch to have like its own solid grayscale value, which it doesn't. So for now, I'll be just returning to 1. And then, well, I need to go and figure out where to put things. And I think what happens is that this is where I should put my random value. So this is when things are getting passed to this one. Or maybe even I think maybe even at the, I mean, no, not at the top. Definitely not at the top. Let's try it here. Do I have a random value here or already? No. Do I have another random value here at the top? I know that I already have a random value and I don't know how it's called. It's R1 or something, but I don't remember where I created it. Okay. For now, I think maybe it was here, the random value. Well, okay, don't worry about it. I'm just going to create something here. So float, it's going to be 1, it's going to be a random. It's also going to be stored in a value, so set in a variable. It's going to be called RRR, just to make sure that I'm not overwriting anything else. Sequence. So this here, and this here. Now everything is connected correctly. And then go into here, I want to use that variable. So get float RRR, right? And set it as an output. Yeah, so this is what I wanted to achieve. And I think also you can see that it's doing it, but it's doing, I mean, I have the same thing going on for the V-shapes. So I wanted maybe even more randomness. Maybe I want to have each one of them random. So, okay, I tested it here. I tested it here. I mean, no, not here, where I actually put it. I think I put it here. Yeah. Let's go downstairs a bit. Maybe here I should put it. Yep. So float 1 random set RRR2, and I can just plug this in here already. I had a set sequence node waiting for me. And now here, I think this might work if I just put RR2. Yeah, I mean, yeah or not? It seems like it changed things, but it didn't. It still do the same. So we're going to try one more. So we were here, and yeah, I actually think it makes sense. I don't know why. I think this is the place where we actually put it. So another one here. Float. Yeah, I think here it is. Set. So maybe do RR3. Yeah, this did the trick. So if you put like a random directly here, is going to colorize each point. If you put it in here above, it is going to colorize each line. Okay, now the entire effect is a bit too strong. Yeah, so I don't want it as strong as this one. So I'll be just linear interpolating between 1 and this random 3. So lerp, and then float. And here I'm just using kind of like a regular blend node. So everything is now white, and then once I increase this, I'm going to see more randomness going on. So I think maybe around 0.6 might be good. I might be changing things after that, but I think it's good. So what else should we be doing? Well, I think we should be curving those a bit and add a bit of randomness to the angle here as well. So we currently have this. Where do we want to add the curveness? Well, here we want to this value. Yeah, this is doing it for us. We can just add and get float and T3. Okay, I think this might be too much, so we need to multiply t3 by something smaller, something like this. Float. Okay, maybe should we also try the different ones, or what happens if I negate this? So it gets spread. I think, yeah, this seems to be a bit more interesting, but maybe I can do something like this. So T3 is this one, negative 3 T3 is this one. Maybe we can just use the randomness that we created. So get float, and we have the RRR3. This is coloring all our branches with random values. And then we want to kind of switch between those two things together based on this randomness. So maybe first of all do a lerp. And I don't know how this might be looking good or not at all good. So we're randomly switching between this and this. And it looks like this, which I think it's not bad. Not at all bad. Yeah, I think it looks quite natural. Maybe increase this. Okay, maybe it's too much. I think it was a bit better before. Okay, something like this. Yeah. Okay, so we have it like so. And then let me get back to it and then just increase the luminosity of the branch, the main one a bit. Go with this one as well and increase the luminosity like that. So what else can we do? I wonder if we can add some like flowers or fruits to this branch. Should we try it? And where should the fruits be? Well, for now I can do another thing that I just noticed that might be looking good. Well, I want the brightness of those branches to be like more bright here at the edge of the leaf, and then more dark inside here. So for example, I don't like how bright those small branches are here. And let me just do that. So into luminosity, we already have this going on, and I want to multiply this by something smaller to get it darker. Something like this, so everything gets dark, and maybe even more dark. Like this. And then I just want to blend between this and this, and we want to blend along each of those secondary branches, and we have it. So we have the T2 parameter. So lerp for linear interpolation, and then get float 2, get float, it's T2, and then set, and then set. Did it do it? I don't know. Seems weird. Let me... I think it's T1 actually. Yeah, we never had T2. We only have T0, T1, and T3. So let me get here and just set T1. Okay, and maybe it's in reverse. Yeah, so this is what I wanted. So maybe I can just even multiply. So yeah, everything gets darker toward the center. I can darken this as well. maybe here, just darken it a bit more. And also I will darken those things as well. So these are this one, and it's just like get float, it's T1. Okay, and then I just need to increase them, so maybe it's like lerp between two values that I'm just going to eyeball. Set. Now everything is 0, so I don't know which one is which. Well, maybe this one is 0.17 and then this one is going to be like lighter. Okay, so now we have it, and then just put some fruits at the top. Well, I'm just going to, I don't know if it's going to look good or bad, but I'm just going to do it anyway. Maybe if we don't like it, we can just remove it, but I will be putting some like fruits at the top of some of those branches, right? So for this, we want to just do another branching from here. So switch this and this. And I don't think at this point, I don't think we need to do any transfer from here to here. Maybe we will, I don't know. Just for the sake of it, just do this. Yeah, let's do it. So copy, go in here, edit, paste, sequence, do this, put a dummy boolean, so it's false, that's good. Set this one as an output for now. Everything got double length. Go in here, just use this thing, delete everything else, delete, delete, delete. Okay, perfect. And then what do we want to also do here? We want to make things a bit more organized. It's kind of messy already. And then set this for good measure as ANG2. So we have angle 1. We want to set it as ANG2 in case we ever need it. And then sequence. Okay. And then we need to maybe take this one, put it in here. For the size, just do maybe 4 or 5 times. Okay, and then just want to put things here like close to the top. The fruits should be like very close to the top. So for this, just going to take ptnum3 and numpt3 and then say like, hey, equal, if this equal to this minus maybe 10, then output this. Okay, so we have a lot of fruits. Well, kind of a lot of fruits if you ask me about. It's looking interesting. We should use randomness to clear a lot of this. So we need to add more conditions here. Do we already have some randomness that we use? I think we already have. Maybe get float r3 greater. So what I'm going to say, like for only for those branches that are brighter than some value, then I would put the fruit, right? So maybe I would say 0.95, and we're going to add this additional condition by doing an AND. So we're going to say like, hey, respect this condition and this condition as well. So only if those two conditions together are met, then you show the fruits. Well, I think this is already better. And maybe we can just add some randomness to them. I really like how it took the actual size of them, but I want this to happen in reverse. So you can see that we have like large fruits at the bottom and smaller fruits at the top. Maybe it's make more sense to have larger fruits at the top and smaller fruits at the bottom. I don't know, because of light or something, you should have more of this at the top. So how to do this? Well, the size itself it's already conditioned by thickness. Maybe we should just invert the thickness and be prepared to see some really, really gross large things together, because these are already small. If I invert these numbers, I'm going to get really large things. I hope it's not going to crash. Yeah, probably it's safe. So 1 minus. Not this, sorry. On it. 1 minus y. Oh, it doesn't work like that. Yeah, so yeah, maybe just subtract this and load 2. So I couldn't put a 1 minus because this is a float too, and 1 minus only works with floats. This is like really, really big, but maybe I can just do. Yeah, I think this is. Well, it seems like it doesn't work too good. It seems that everything is like maybe thickness, 1 minus thickness. Doesn't seem to like it. Maybe I can just swizzle it. I can make it like not dependent on the thickness. Maybe the fruits, I don't know, maybe X and Y. Just let me try this. I'm just trying to see if this is different than this. I don't think it should be, but I might be wrong. At this point I am a bit tired. Yeah, so it's not making any difference. Well, in this case I'm just going to use my other thing. So what I want to do, I want to use my t0 variable to make fruits smaller uh, at the beginning and then larger here at the top. Okay, so how should I do this? Well, I should get the t0 and just scalar multiplied by, so make a vector out of it and then do this. Yeah. Okay, so now we're having fruits as well at the top, and then if you change things randomly, everything changes. So now you're having a branch generator, which I think looks cool. And I want to do a few more things. I want to relate the length of the branches to the main one to have them like a percentage out of it. So currently they're individual. So here is where I store the Where is my length here? Okay, yeah. So I want to relate this at this level here. I generate the length of these branches, which is in here. So it's already, I think it's already related to T0. Let me change the length and see what happens. I think they might already be linked together, which is a good sign. And I also need to make this floor to make sure that things don't get crazy. Okay, why don't you want to work? 124, maybe integer 124. Okay, to float, have it like so. And then if I play with this, okay, this is not good, but I think we might be able to fix it. So let me have a look at it. Okay, so the problem is that when we are changing this number, everything disappears. And the reason for that is because here, one level down, when we do the branching, we've done it like so. So we're taking the the numpty and we divide it by 32 just to specify how many of those branches we want. But then if I change this parameter, kind of it doesn't work okay. It should be like things that are maybe multiples or squares of 32. I mean 32 multiplied by 32, it's 1024 if I'm not mistaken. So whenever I change this, kind of it breaks this proportionality. So the easy fix is just for now, you instead of specifying like how many branches I have, just to say like spacing between branches, so spacing. And then instead of doing this division, we just take this thing and put it here. So nothing changed currently, but then if I go here and change this 124, then everything is going to work. Yeah. Okay. And look at that. It's pretty awesome to have a look at it, right? Okay. So now the cool part is we made it so far and we like it. And then this is how you should build procedural systems, because now that you have this thing, um, this system in place, um, you can use it and you can duplicate it and you can have multiple copies of itself. And all those copies are going to be individual because we have randomness and various parameters that allow you to control the individual aspects of each individual instance, and this is really powerful and amazing. So for example, if you wanted to do something like this that changes in Substance Designer, you would have to do like some tricks. But now that I have these leaves, what if I want to make multiple leaves? What if I want to make copies of this? Well, let's do it. So um, first of all, I'm just going to take this and orient it a bit in in a more vertical direction. So I think this is what I want to do. And then just take this one and move it down a bit. So this is where we move up and down, and also move it like, I think it's good where it's right now. And I want to just decrease its length. So we test and we saw that it's working. So now I want to just have a leaf like this, and I want to make like an evolution. I have one leaf and then I want to have them maybe 2 or 3 or 4 leaves depending, or probably 3 leaves, and they should be increasing, right? So how should I do that? Well, because I already have everything in place, I can just go here and do another iterate node. So this is another iterate node that I can use. Well, currently it's only doing 1, but it can be doing 3. So if I'm doing 3, it's going to generate like 3 things in place, and we should probably see this thing going crowded more because we have randomness. So maybe 3, yeah, everything like the main stem remained the same, but all the other things changed. But then we can go in here and say like, okay, we have 3 things. We go in here where we defined our position and we can add to it. So add, well, we don't want to move anything vertically, but we want to move things horizontally. So we create a float 2 like this, and then we want to float 0 so we don't move vertically, but then we're going to move it horizontally like so. So this is moving everything all together, but we want to move it like one instance or one copy or one leaf at a time. So of course we have our get float $number. This $number that I just called comes from this one, okay? So $number, I want to multiply it by a small value, float, and just see what happens when we change this 0. Okay, so we have 3 copies. Well, awesome. Now I have 3 copies, but what else can I do? Well, I want to use this thing to change this number here. So we had this, and let's do a larger one. So maybe this, where all the leaves grow. Okay, and every one of them is different. They look similar, but everyone is different. You can see like at the fruits, we have 3 fruits at the top, we have 1, and things like that. So now we can just use the number here, $number. We divide it by 3. Okay, and then we use to lerp between this and this. So lerp, and those things need to be turned into floats for this to work. So float, sorry, it's to float because we want a conversion. I mean to float, integer to float, where is it? This one. And duplicate it, and then plug this thing here, and then like so. And now this needs to be just like this. Okay, so we had 3 leaves. And let me do it a bit more proper. So I'm going to put this level as -1, -1, and go inside. And instead of having it like so, we're going to do like a float, maybe 4 this time instead of 3, because I want 4 leaves. And I also want to set this as numpt -1 and sequence. And up to this point I didn't encounter any problem with if I name my variables with like a math sign or math symbol here. It seems that it doesn't do anything wrong, but I don't think it's a good idea to use this for variables. But yeah, I mean it works. So to integer, okay, set this as an output. I get 4 leaves. Then I need to go here get my dollar number, set it to ptnum minus 1, use the sequence node, create my t minus 1 variable, so get float. We have ptnum minus 1 already. We duplicate this and num pt minus 1. We do this division. We set this to t minus 1. We plug this thing in here. We do this sequence to chain all the info together. Now we get maybe instead of dollar number, we're going to get like get float. I want t minus 1 here. Now this crunched things together, that's fine. Okay, so we have 4 leaves. Then here I want to layer between this based on t minus 1.